What's up guys? Check it out, I just successfully upgraded my stock Ender 3's motherboard to the MKS Gen L version 1.0, and I didn't stop there. I also upgraded the stepper motor drivers to the TMC2208. I'm super happy, everything is working. So exciting. Currently I'm doing a test print, and what best to print if it's not good old 3D Benchy. Have a look. It's amazing, it's almost done, and I'm really happy with the outcome. Everything looks great. Let me show you the board. This is the MKS Gen L version 1.0 board. Sorry for the mess. This board has a much more capable microcontroller. This is the Edmega 2560, has a larger number of pin count and also a bigger flash. It does not have a SD card slot, however, and I'm currently hooking up to my Raspberry Pi via USB. The Raspberry Pi is running Octoprint. What I noticed immediately after the upgrade is the motors are almost dead silent. I don't hear any noise. No screaming, no screeching, no whining, nothing. They are quiet. Whatever Trinamic did, it's amazing, it's good. It's borderline magical. I'm really impressed. All the noise that you're hearing is coming from this parts cooling fan and also the hot end fan and the fan from the power supply at the back. These are the TMC2208 drivers. I have 4 of these plugged in, 3 for the axis and the other one for the extruder motor. These run uncomfortably hot. There's no way I can leave my finger on the heatsink for more than 5 seconds. And they tend to drive the motors hotter than the previous board. Currently they are configured in standalone, or also known as legacy mode. So stay tuned and I'll be showing how I got to this point. Hey guys, this is Jugnu. You can also call me Jay. Today, I'll be sharing all the changes I've made to upgrade my Ender 3's stock mainboard to the MKS Gen L version 1.0. I'll also cover the configuration required for the upgrade of the stepper drivers to the TMC2208 drivers. I'm doing as minimal a change that's possible, but we do end up losing SD card functionality with this upgrade. Let me repeat, SD card functionality will be lost with this upgrade. You'll need to purchase extra hardware to get the SD card functionality back. In my case, it didn't matter as I'm running Octoprint via my Raspberry Pi, so do take note. I'm going to kickstart the video by tackling the software side of things first. Later, there would be a section where I'll cover the hardware configuration. So for the firmware specifically, we'll be configuring stock Marlin 1.1.9 so that it'll run on our Ender 3 installed with the MKS Gen L version 1.0 board, together with the TMC2208 stepper drivers. The exact hardware I'm using is provided in the links below, so do check it out. In brief, we'll need to make only 3 changes if you have the exact same hardware that I have, and these are: first and foremost, we'll configure stock Marlin 1.1.9 for Ender 3's use. After that, we can proceed to configure the resultant Marlin 1.1.9 for the MKS Gen L version 1.0 board. Finally, we'll change the default stepper drivers from A4988 to TMC2208 for standalone operation. However, if your TMC2208 drivers are not the same as mine, then it is possible that you would have to invert the direction of your drivers in Marlin. This is, however, an extra optional step. I'll show you where that change can be made, but for now, we'll be making the 3 changes that I just mentioned. So let's head over to Marlin's GitHub page and download Marlin version 1.1.9. You can either follow the link provided below or Google for Marlin GitHub. Just for demonstration, I'm gonna Google for Marlin GitHub. So from our search result, we are interested in this first entry here. We're gonna click on this and follow this link. It'll lead us to this page. All we have to do now is navigate to this green button over the far right, which reads clone or download, and click to choose download zip from the pop-out combo box. Click OK to save the file. And once the file is saved, you're going to click on the download to see what file has been downloaded. The file which has been downloaded is named marlin-1.1.x.zip. I'm going to head over to my downloads folder where it has been downloaded for my case. So this is the firmware which has been downloaded as a zipped archive. I'm going to extract this file by simply doing a right click on it, choosing 7-zip, and extracting it here. This would extract this archived zip file into the folder marlin-1.1.x. Now for the first change, which is getting the stock Marlin firmware ready for our Ender 3, we'll need to navigate into the folder which was just uncompressed. That is marlin-1.1.x. Double click on it and head on down to the folder named Marlin. Once in Marlin, double click on example_configurations, followed by Creality, and then Ender 3. Once here, we're going to copy all these files with a right click, copy, and head on back to the folder Marlin. Once back in the Marlin folder, right click and choose paste. We will select to replace the files in the destination. And this ends our first part. Now, our stock Marlin firmware version 1.1.9 is ready for use with our Ender 3. Next, we'll need to change the stock motherboard to the MKS Gen L version 1.0. So search for the file marlin.ino and double click on it. This would open the Marlin firmware in the Arduino IDE. I already have mine open over here. Now if you don't have Arduino IDE installed, then head on over to the link for Arduino provided below to download the Arduino IDE. The one that I'm currently using is at version 1.8.5. Once downloaded, double click on the installer to install it. I wouldn't cover the installation portion of the Arduino IDE, as you can get that information from the Arduino site itself. So let's navigate to the tab which shows the configuration.h file. Scroll down until you find the section on motherboard, or just do a find for it by doing a Ctrl+F. Here it is set to the default, which is board_melzy_creality. Next, we need to select the tab labeled boards.h, and we can do that by clicking this drop down arrow in the upper right corner and selecting for the file boards.h. This file contains all the definitions for the main boards which are supported by Marlin 1.1.9. Scroll down for the definition of our new board, which reads board underscore MKS underscore Gen underscore L, and double click on it. Let's right click on it and select copy. Let's head back to our configuration.h file. Double click on board underscore melzi underscore creality. Right click on the selection and choose to paste. This would replace our previous main board definition with our new one. With this, we now have completed the second change required in the firmware. Control S to save our changes before going any further, or select it from File and Save. For the final change, do a find by typing Ctrl plus F for TMC2208. Scroll down and replace the default driver A4988 with the TMC2208 underscore standalone for the X driver type, the Y driver type, Z driver type, and E0 driver type. We can easily do this by copying TMC2208 underscore standalone from the option list in the comments by a double click for selection, followed by a right click, choose copy. Let's select with double click the driver definition A4988 for the X driver type, like so, followed by right click, choose paste to replace. Repeat this for the Y driver type, Z driver type, and E0 driver type. Once that's done, we'll need to remove the double slashes from all the lines that we have made a change on. So that will of course be the X driver type, the Y driver type, the Z driver type, and lastly the E0 driver type. Ctrl plus S or File, choose Save, and that's the final change that we need in our firmware. An optional change may be required for other hardware variations of the TMC2208 stepper driver, and that is related to the drive direction. You may have to reverse the setting in the firmware if you find at the end of the firmware and hardware configuration that the stepper motors are running in reverse. If that happens, then do a Ctrl plus F and search for invert underscore X underscore dir in the file configuration.h. It will lead you to this section. Now reverse all the entries related to our setup. In our case, that will be for the definitions invert X dir, invert Y dir, invert Z dir, and invert E0 dir. Reverse here means change the true to false and vice versa. Remember that you only need this change if you are sure that your drivers need to be inverted beforehand, or from observation during a test run at the end. Okay, we are almost there. Before we can hit the verify button to start a compilation, we'll need to install some dependencies. These are the u8glib and TMC2208 stepper libraries. u8glib is for the stock LCD on the Ender 3. You may already have this one if you have updated the firmware on the Ender 3 before. The other library is for the TMC2208 stepper driver. I'm going to show how to do it for the stepper driver, and you can repeat the same steps for the LCD driver if you need it. Click on Sketch from Arduino's main menu and choose Include Library. From the drop-down, click on Manage Libraries, and this would pop out the Library Manager. Type TMC in the search box and choose TMC2208 stepper. Click on the Install button to install the library and wait for it to finish. You should see a blue Installed caption right next to the library we just installed, like so. Now for u8glib, clear the search box contents and type u8glib. You may have to scroll down to look for it. Check to see if it's installed, otherwise proceed as before. That's it. We are now ready to compile the firmware. Hit the Verify button, which is located on the upper left corner of the Arduino IDE. This is the button with the check mark on it. Click on this button to start a compilation. Wait for it to finish. This compilation should take anywhere from 3 to 5 minutes depending on your hardware. Once the compilation stops, check in the message window for the final message. If it was successful, you would see the program space usage of our firmware. This indicates a successful build. Let's get our board and connect it to one of the USB ports of our PC. Prior to that, launch Windows Device Manager so we can observe for hardware changes when plugging in our MKS Gen L board. I already have mine open down here. Let's plug in our MKS Gen L board. Wait for Windows to complete installing the driver. We have to make sure that the right driver was installed for the serial port on the MKS Gen L board. Observe this under the category Ports, Common LPT. The right entry should read USB serial CH340, and in my case, my port is installed under COM6. Head back to our Arduino IDE. Now, we would have to configure our MKS Gen L board and the COM port it is attached to in the Arduino IDE. To do that, we will proceed to Tools and go to Boards, and under Board, select Arduino/Genuino Mega or Mega 2560 if it's not already selected. Go back to Tools and ensure that the processor is selected as the Mega 2560 or Mega 2560. Go back to Tools one last time to select the right COM port where your MKS Gen L board is attached. In my setup, it was installed under COM6, so I would select COM6. Once that is done, we can now proceed to the upload button. The upload button is the one which has a little arrow in it. Hit upload to start the upload process. Wait for it to complete. This should take no more than 3 minutes. You would know that the firmware upload is complete when prompted that the uploading is done. This completes our firmware configuration. All we have to do now is attach our board to our Ender 3. That will be covered in our hardware configuration section.